Okay, grade 9 students, let's start our today's lecture. Our today's topic will be based upon our previous topic, in which we have derived a few equations of motion. Okay, there are basically three equations of motion by graphical method. First equation, v is equal to u plus at. It was, that is, velocity time equation. Next equation was s is equal to ut plus half at square. It was position time equation. Okay, and last one, v square minus u square is equal to 2as. It was the position velocity equation. Using these three equations, today we shall learn how to solve numerical problems. I have written two numerical statements here. First numerical is like that: a car accelerates uniformly from 18 km per hour to 36 km per hour. Please note down these 2 points. In 5 seconds. Means velocity of car is changing from 18 km per hour to 36 km per hour in 5 seconds. We need to calculate the acceleration with which the car is moving and distance covered by the car in this much time. How much time was there? 5 seconds. Okay, dear student. So to solve, yes, it is in the picture. To solve first numerical, so velocity was changing from 18 km to 36 km. Hence we can write down initial velocity as 18 km per hour. Okay, to change it into meter per second, let's divide it by 5 by 18. Okay, such that this will be 5 meter per second. Similarly, v is equal to 36 km per hour. After changing it into meter per second, please look at that. To change in meter per second, we are multiplying by 5 by 18. Why? Because for kilometer we are using 1000 and for hour we are using 3600 second. When we will cancel out it, it will be 5 by 18. So dear student, by multiplying 5 by 18, the given magnitude of the velocity, we can calculate it in terms of meter per second. For numerical solution, these changes are required. If time is given in minute, it should be changed into second. Time is already given in second, hence time is second. Okay, time is given 5 seconds. So using this relation, first we need to calculate acceleration, and formula for the acceleration is equal to v minus u divided by t. That is, v is final velocity is 10 meter per second, initial is 5 meter per second, and total time is 5 seconds. Hence it comes to be 5 upon 5, that is 1 meter per second square. 1 meter per second square. This is the unit of acceleration, meter per second square. Hence acceleration will be equal to 1 meter per second square. Second point, we need to find out the distance covered by the car. So distance can be calculated either by this formula or either by this formula. To calculate distance by this formula, we need initial velocity, we need time, we need acceleration. All the three quantities we are having there. Okay, so we can use this one also. Also we are having v square, v and u, we are having acceleration, we are having. So my dear student, here we are going to use this formula. It will make our calculation little more easy, and with the help of these two formulas, same answer will be there. Okay, I can prove it if you want. First, let's use this one. To find out distance traveled, use this formula: v square minus u square is equal to 2as. So put all the required value. V was 10, u was 5, and 2 into acceleration is 1. We have just calculated from here, and distance we need to calculate. So square of 10, 100, minus square of 5, 25. It comes to be 2s. Hence it will be 75. 100 minus 25 will be 75. Divided by this 2, it will be s here. So 75 divided by 2 will be equal to 37.5 meter. This much distance will be covered. Same can be also shown by another formula. It's your wish here. We need to look at what is given to us. Okay, if any two variables are given, we can find out the third variable by using this formula. S is equal to ut plus half at square. Let's calculate s. U was 5, t was 5 seconds, okay, plus half, acceleration is 1, t is 5 again. So my dear student, 5 5s are 25 plus 25 by 2, 25 plus 25 by 2 will be 12.5, and it will be 37.5 meter once again. So from both the formulas, distance travel is same. We can use any relation to calculate the distance traveled. Let's do one more numerical. That is second numerical is written over here. I hope you will be able to solve. Only it is possible if you are doing proper practice, because practice makes a man perfect only. So my dear student, let's come to the second statement. And second statement is such that a train starting from rest. Please note down this point. Train is starting from rest. So for solution, just write down this point. Means initial velocity was 0. When object was at rest and initial velocity is not given, so just put u is equal to 0. Initial velocity at once हमें क्या करना है, 0 पुट कर लेना है. Attain the velocity of 72 km per hour. So velocity attained, कितना velocity acquire कर लिया उसने ट्रेन ने, it is 72 km per hour. So it can be changed into meter per second. To change into meter per second, multiply it by 5 by 18, such that 18 4s are 72 and 4 5s are 20 meter per second. This is the final velocity attained by the car. Time given is equal to 5 minutes. This minute should be changed into second. To change into second, 1 minute is equal to 60 seconds. We need to multiply. Hence 300 seconds will be the time taken. Please make sure why we are changing this unit of system. In detail you will learn in higher classes. Basically in 11th class, if you choose physics as one of your subject. Even in chemistry you can learn these things. But here only you remember that we are just selecting one standard system of units in which length is always measured into meter and time is always measured into second. That's it. That's why we are changing all the units over here. So now we are having u, v and t. We are having what we need to calculate, assuming that the acceleration is uniform. Find acceleration means let the acceleration is uniform, and we need to find out this acceleration and distance traveled by the train to attain the velocity. Okay, my dear student. So what we can do here to find out acceleration, we are having final velocity and initial velocity. V minus u, we are having time. So using this relation, we can calculate acceleration. Final velocity was equal to 20 meter. Initial was 0. Time was 300. It will comes to be 20 by 300. 10 will cancel out with this one. It can further written as like that 2 by 3, and or you can simply write down this 1 by 15 meter per second square. This will be the acceleration, uniform acceleration attained by the train. Now we need to calculate distance traveled by the train to attain that velocity. Okay, so now in previous numerical it was given what will be the distance covered by the car in that time. Means distance time relation we need to calculate the distance in our previous numerical. So directly we can use this one. Now it is given in the statement, distance traveled by the train to attain that velocity. Means we have to use position velocity relation, that is this last relation, position velocity relation, to calculate the distance traveled. Hence by using this relation, v is equal to 20, u is equal to 0, 2 into acceleration is equal to 1 by 15, we have just calculated, and multiplied by s we need to calculate. So my dear student, 20 square will be 400, or we can simply write 20 into 20 is equal to 2 divided by 15 into s. Further we can write 20 into 20, 15 by 2. Okay, so it will be 10, and it is going to be 30,000 meter. So this is how we can use a particular relation to find out the desired answer. Here we have used position velocity relation, because at last the statement is like that ki what will be the distance traveled by the train to attain the velocity. In previous first numerical it was given what will be the distance covered by the car in this given time. Means distance time relation there we have to use. Okay my dear student, let's try a few more numericals. One more numericals we are going to solve. After that you need to practice more and more. So one more numerical is given here, and let me write the statement just. Okay, next statement is ready for you my dear student, and statement is like that: a train is traveling at a speed of 90 km per hour. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. Find how far the train will go before it is brought to rest. Means कि once again we need to calculate distance traveled by the train as soon as it comes to rest. Means the body will be in rest if final velocity is 0. If final velocity is 0. Initial velocity of the train is given 90 km per hour. Okay. Then brakes are applied. Brakes are applied. Brakes applied only suggest that deceleration or retarded motion. There are different names. Retardation or deceleration will take place whenever we are using that brakes. Brakes apply करते क्या होगा बच्चों? Speed will slow down. When speed will slow down, acceleration will also decrease or slow down. Hence the decreased value of acceleration is shown with negative sign. Decreased value is shown with negative sign. So let's calculate the required things what they have asked. They have given a statement, a train is traveling at a speed of 90 km per hour. Brakes are applied so as to produce a uniform acceleration of minus 0.5 meter per second square. Find how far the train will go before it is brought to rest. So for solution, my dear student, u is given to us. Initial velocity here it is 90 km per hour. Once again, let's change it into meter per second. What to do? With which we need to multiply it to change into meter per second? Yes, we need to multiply it with 5 by 18. Then 18 5s are 90 and 5 5s are will be 25 meter per second. This is the initial velocity. Whenever there is a scene like that, brakes are applied and statement is like that, what will be the distance covered as soon as it is brought to rest. Brought to rest means such that final velocity we need to choose 0 over here. Okay, my dear student. So what we need to calculate? We need to calculate the distance traveled. So using this formula we can easily calculate. Formula is v square minus u square 2as. Since acceleration is given to us and we need to calculate this distance over here. So initial velocity, final velocity is given as to be 0. Initial velocity is given as to be 25 and 2 into minus 0.5 into s. Hence, my dear student, it will be 25 into 25, it will be 625 with negative sign, and it will be 2 into 0.25, it will be 1.0 with negative sign into s. Okay, into s, or simply you can say that 1 will be there. 1 will be there means it is half, and half into 2 will give us 1. So minus will cancel out minus, hence it will be 625 meter. Okay, just okay, my dear student, this is the final numerical problem for today. Please try to solve the remaining problems. I will send you a worksheet to solve. Okay, if there is any problem, you can ask me by putting a message in the comment, or just WhatsApp me on my personal number that I have shared with you earlier. Okay, thank you for watching.